now that we've talked about the data repository specifically, we can talk about the resource system as a whole. So as you can see, the data repository was a system for distributing data through the Wolfram language and through our cloud. But we can do much more than data. So the resource system is going to have lots of repositories, each one defined by their particular content. So it'll be divided into repositories and resources and the parts. So we're going to talk about terminology a little bit. We're going to talk about publisher accounts and what you need to submit for publication, and then we're going to spend most of the rest of the time talking about these 4 repositories besides data, since we are talking about that. And really, we're just glancing over Neuralnet. So we'll look at 3 new ones that are coming: demonstration repository, function repository, and formula repository. And then we'll have another demo of creating your own resource. This time, instead of data, we're going to look at function resources, and then a brief preview of what's coming in the future for the resource system. The resource system is divided into repositories, like I said, each one having its own content type. So we already saw data content, and we're going to see a lot about neural network content later. And in general, repositories have websites. They have functions that integrate them into Wolfram language. Different resource types are integrated in different ways, and they have metadata that's specific to the repository. We already saw this for what a resource object is and how to look at its metadata. So we won't necessarily go into that again here. But what we should talk about now is publisher IDs, which I alluded to before. If you want to submit, what you need to do is request a publisher ID. You can do that on the data repository website here. Just tell us who you are and what you want to do with your publisher ID, and that'll be reviewed by someone at Wolfram, and if we like what you want to publish, and then we'll give you a publisher ID. And once you have that, it's not limited to just a data repository, even though that's where the form is. You can submit a neural network or a function once that's live, or any resource type. In addition to reviewing requests for publisher IDs, we also have human beings that will review the submissions of resources to see what we want to include. And I already talked a little bit about what we're looking for data. So data repository, that was released almost a year ago now, and the content is data. We already spent 20 minutes, 30 minutes looking at that specifically, so we won't dwell on that. The next repository is the Neuralnet Repository. I won't go too deep here because Megan's going to go in depth in her talk that's coming up after this. So feel free to play around with this example in the notebook that's been distributed. But I will just point out that all of these repositories have this share the interface of using resource objects. So you can get a resource object, you can use the name, and here it's a neural net resource instead of a data resource. There's some metadata that's consistent between all resource types, like details is a consistent text field for all resource types. Content elements is consistent between neural networks and data resources. Resource data is the same. It works the same for neural networks as it did for data resources, but it won't necessarily be that way for all resources, as we'll see. So this sort of gets the net chain, and I won't go any further because that might spoil Megan's talk. The third repository, which is kind of slowly, quietly being released as we move on, is the demonstrations repository. So the demonstrations project has been around for a decade, and it's great, and there's great content here. This is all user-generated dynamic content that creates manipulate objects or animation objects that show great things. One drawback of it, though, has been that there's this website where, in order to actually use the thing, you need either download a CDF or you download a notebook, and it's not clear how you do this. So the interface with the Wolfram language could be better now that we have the resource system. So that's what we've been doing. So now you can just take the name of the demonstration and put it in a resource object. You can, just like we've seen before, you can see metadata. Authoring information is one that we have for demonstrations that was different than what we had in data resources. And we have the symbols used, which is kind of neat. This is a new metadata field that we've added that shows you all the symbols that the author used to create the demonstration. And then using resource data gives you the actual animation. So this is much nicer than downloading a CDF or a notebook that has a whole bunch of stuff you might not care about in it. You can just sort of go straight to the main event, which here is this manipulate. So there's over 10,000 demonstrations. We've been gradually moving them over to the resource system since there's some manual extensions that we're doing to the metadata. It takes a little bit of time, so we've probably got 2,000 or 3,000 done, and they're slowly being migrated over. But this is using the resource system to add Wolfram language integration to a website that's already existed. Formula data is the opposite story. So formula data has been around for a couple versions of Wolfram language now, and it's got 1,000 formulas in it. If you've used formula data, this is not particularly interesting to you because this is sort of a thing that we've had already. You can see a table, you can apply values to it and get results. But what we're doing, what the resource system has allowed us to do with this is to add a web interface to the Wolfram language content that's existed already. So if we can look at a preview of what this is going to look like. So this is hot off the presses. This is not publicly released yet. So I guess it's not off the presses, on the way to the presses. So this is what the formula repository will look like soon. So you can look at within these domains, you can see, give me something from the domain of physics that has an equation involving mass. So this, okay, so maybe, okay, there we go. We only had one with mass. But you can, gravitational acceleration. I'm surprised there's not more with mass in physics. And just like the other ones, each resource has its own page where there's a name and a description and more details. And you can do things like copy the formula directly into a notebook. Let's open a new notebook and just stick it in here. You can see here's this set of equations describing, I don't even know what a polytropic process is, but I can learn about it. It's a thermodynamics thing. But then the interesting thing is we have these forms. So let's just change a bunch of these things from what it's suggesting. Change units around, and you can mix things up. We can combine English and standard. If I'm putting in things that are ridiculous here, let me know. Ooh, I'll just do that one. I'm not gonna. And I can submit this thing, and I should get. Okay, so this is why it's still coming along, because some of these formatting are there. But this is correct. It's just formatted poorly. But you can get your numeric results for these forms right away, just in a web form that's out there. And again, these have examples that right on the website, so you know how to use it. And you can open the notebook in the Wolfram Cloud, or you can download an example notebook. So let's look at that. We can take that guy and immediately open it up so we have the same examples here. So the formula resource, unlike demonstrations where we were adding Wolfram language integration to a website that already existed, here we're introducing a web interface to Wolfram language functionality that already existed. So the last repository is one that I think people are going to be excited about. That's the function repository, which is going to allow you to sort of extend the Wolfram language with functions that, for one reason or another, we don't really think are worthy of putting into the top level Wolfram language. So they can be simple utility functions. Here's one that we have called lookup sequence. If you're familiar with lookup, it sort of works on the first level of a data set. Yeah, we won't look at the documentation. It sort of looks at an association at the first level. This is something that we've made that can go deeper parts. So what this works is you take resource function on the resource object, and you get this little blob. If you have some nested data structure, you can use this blob and apply it to the data, and you can say that Suzanne's hobbies are playing poker, but Fred has no hobbies, so he's boring. You can supply this default. So this is a little utility function that might not be worth being a system level Wolfram language function, but it might be something that we put into the function repository. Another thing that we could put in there is something that's a little like more esoteric, or has a narrower usage base than maybe everyone who uses Wolfram language. So here's something that we're calling symbol dependency graph. So this takes a symbol and shows you what other symbols it depends on and builds a graph out of the dependencies. So here A depends on B and C, B depends on C, and C doesn't depend on anything. So you can see here's A, B, and C. Here I'm applying that same thing to what's actually the function underlying this resource function. So if I have this resource function here, if I use symbol on that, there's an underlying function that's ugly, but that's sort of a symbol that underlies this dependency graph resource function. And I can apply it to itself and create this graph, so you can see all of the other functions or symbols that are dependent on it. So this is sort of a neat demonstration of a way to visualize your code. But again, it's sort of a gimmicky, esoteric thing that will be fun for programmers, but maybe not a system level Wolfram language thing. So to show how all these things sort of fit together and how all the repositories are part of an integrated Wolfram language system, what I've done is sort of combine all these different resource types into this one example. So here I'm getting a data resource about our solar system, and I'm grabbing data about Europa, and I'm using lookup sequence, that function that we had before, to grab data about Europa. And then I'm applying it to the formula for gravitational acceleration. And when that all works out, we get a WDF, a quantity object of 1.31 meters per second squared. I can check Wolfram alpha to see if we think that's correct. And when we convert it, yeah, so down to some rounding, Wolfram alpha and the resource system agree. So that's sort of how everything is well integrated together. So the next thing we want to look at is creating your own resource. We did this with the data repository in the last presentation. So now we're going to do it with function repository. Something that's brand new now is a definition notebook for function resources. So just like data, you can fill this out and to create a function resource. You can also do it programmatically, which is what I have made in this demonstration. So here I have a function I made called find a celebrity. It uses find faces to on an image to find an image, and then it uses classify to find a celebrity in that image, and then it uses image trim on the faces, and it then applies this click pane so that if you click on a name that we put on the face, it'll get Wikipedia data and it'll print it out for us. So that's a little function I made. It's not too complicated, but it makes something sort of fun. If I click here, it'll tell me about Michael Jordan, and I can use my webcam to get a picture of me, see who I am. Sometimes the headset throws off the classifier, and I get something funny. Hunter S. Thompson. Okay, that's not too bad. Yeah. Okay, so now I have this function. I can create a function resource out of it just by adding a little bit of metadata. And here's my function. So I can go ahead and use this anywhere in Wolfram language, and it'll work right away. If I want to deploy this or submit it, I should add a few more things, like I can add some details and some source metadata, and I can create an example notebook. So here's this. I have some simple examples that I created beforehand that I'm just going to replace these default guys with this. So here I can, oops, wrong window. Here we go. Let's put this in here. And then if I do this, see if it gives me Tina Fey. Courtney Cox. Okay, sitcom stars, I guess. So here we have, so that now I can cloud deploy it. And just like we saw with the data resource, you create a web page for your resource object, and these things are copyable, and you can share this with a colleague. So, and if you give your colleague this cloud object, they can just use resource object directly on the cloud object, and they can use it in their Wolfram language session. So if you have a publisher ID, you can also submit this to the resource system. That will give you a submission object, and you'll get a notification email that will tell you that it's being reviewed. I won't do that right now because I don't want to create things that I know will be rejected. So that's a brief summary of the resource system as it is now and where it will be in the coming weeks. Looking out a little bit further, API resources is a big project that we're working on. So we'll have APIs deployed in our cloud that you can access to do computation. Packlet resources, which is sort of like the big brother of the function resources. So instead of just sort of a simple function that you can write in, it's a Packlet that can have source libraries and notebooks and style sheets and documentation and all sorts of more robust behaviors. Device connections for things that you could use on your Raspberry Pi running Wolfram language to connect to something over GPIO, or you could connect to a webcam or something. Service connections. If some of you might be familiar with our Service Connect, that connects to things like Twitter and Facebook and Runkeeper and all of these web APIs. We're going to put that into the resource system so that we can have a web interface for those things. And then a big extension to the resource system will be the marketplace, where we're going to add sort of buying and selling to some of these resources. So a lot of the stuff we already have will stay free, but for users that are contributing things, or if we have some stuff that we're running that really uses a lot of computation in our cloud, and we don't want to give it all away for free, then we're going to add billing to it so that you can buy access, and if you have something cool, you can sell it and make some money. So that summarizes the resource system in general. I have a few minutes before I'm going to have to turn things over to Megan, so we can go ahead and do some more questions. You feel free to ask me things specifically about data repository if I didn't get to them before. Let's see. I have a question. Are publish functions checked for dangerous content like delete file? Yes, absolutely. So for the function repository, yes, absolutely. Yeah. So like I said, everything that's submitted is checked by people, and we're going to look at that and make sure that it's not malicious. Now, a user can cloud deploy anything they want to their cloud account, and they can send you a link and say, hey, check this out. And then, you got to make sure that the person sending it to you is legit, just like any other email you might ever get in life. But for things that are published in our repository, we will vet them. And, there's sort of two steps to that because, like I said, we're not giving a publisher ID to just anyone who asks. And then so we know something about the people who are submitting, and then each submission itself is manually reviewed. Laurent is asking, all data needs to fit in the memory, right? So that there's a max on the data set. That's right. For the data repository, the data all is read into memory at once. Typically you don't want to get anything more than a couple hundred megabytes for users to reasonably be able to use it. We have a couple things that are probably bigger than that, and it's not the best user experience on those things. So that's sort of a rough thing. That's sort of a rough guideline. Of course, it depends on the end user. If they're trying to run Wolfram language on a Raspberry Pi, you're going to want a much smaller limit than if they're running it on some beastly Linux machine.